Hello, I'm Ron Wilson, Editor-in-Chief with Altera Corporation. I'm here today with Shay Verma, Product Manager for Mid-Range FPGAs at Altera, to discuss a rather unusual marketing claim. Shay, as part of claiming a breakthrough advantage on Generation 10 FPGAs, Altera is saying that they've reinvented the mid-range. What do they mean by that?
Well, Ron, if you see what is happening around us, there is a rapidly growing demand for more information through a broad range of devices like computers, tablets, smartphones, the TVs in our living rooms, broadcast equipment, and even military equipment such as handheld radios. Information such as voice, data, picture, and even streaming video are being delivered at an ever-increasing pace. This has caused an explosion in data in the wireline and wireless infrastructure for telecommunications industry. Along with this data explosion, we are also seeing application requirements that rely heavily on power and cost optimization. So communication infrastructure providers are looking to technology leaders like Altera to help solve this problem. They need to provide more information at a rapid pace while maintaining the same footprint and staying within their cost, energy, and power budgets. Keeping this in mind, we had to fundamentally rethink how to help solve the problem. So that is what we did. We reinvented the mid-range category with Arria 10 FPGA and SoCs, providing breakthrough capabilities not possible in the previous mid-range category. These FPGAs and SoCs enable higher performance than previous high-end FPGAs, while simultaneously delivering lower power than today's mid-range FPGAs and SoCs. This allows customers to maintain the same footprint of their existing infrastructure and simultaneously lowering power and cost.
So what exactly did you do to reinvent the mid-range FPGAs and SoCs?
At a fundamental level, we had to select the right process technology to provide a foundation for increasing performance while lowering power through process optimizations. For this, we selected the 20nm SoC process offered by our fab partner TSMC. Now, to further boost the performance, we added a high-performance fabric architecture to the FPGA. The combination of the high-performance fab process and fabric enables Arria 10 FPGAs and SoCs to deliver 15% higher performance than previous generation high-end FPGAs, or 60% higher performance than previous generation mid-range FPGAs. Now, this level of performance is unprecedented in the mid-range class of FPGAs. In addition, we're seeing needs for mid-range devices to deliver terabits of I/O bandwidth. For this, we integrated 96 high-speed serial transceivers capable of supporting up to 28 gigabits per second. That's over 3.6 terabits per second worth of bandwidth. The high-speed transceivers also allow Arria 10 FPGAs and SoCs to connect up to 16 serial memory interfaces, or 4 links, at data rates up to 15 gigabits per second, offering a bandwidth of 1 terabits per second in hybrid memory cubes. The I/O structures are also designed to allow direct connection of high-performance external memory interfaces like DDR4 SDRAM. Arria 10 FPGAs support up to 4 by 72 DDR4 interfaces at data rates of 2.66 gigabits per second.
Okay, so you increased the performance and the bandwidth, but traditionally the word mid-range has also implied a considerably lower power consumption and, in the most recent generation, embedded processors. What about those points?
That's right. The applications we are targeting for these devices need to pack all the important logic into one system-level chip. So we have integrated a dual-core ARM processor, hard memory controllers, more variable precision DSP blocks, and more RAM capacity with over 1 million logic elements into the products. This level of integration reduces not only chip count on the board, but significantly lowers power and cost while maximizing the productivity of chip designers. Basically, a lot more in a single mid-range FPGA and SoC. The power savings, which result from the fab process choice and integrated hard IP, wasn't just enough. So we innovated further by enabling a comprehensive set of power reduction technologies that provide up to 40% lower power when compared to previous generation mid-range FPGAs.
So do all of these improvements mean a reinvention of the development tools as well?
No. Altera has a long history of software leadership, and it continues to develop tools that maximize the designer's productivity. Altera's Arria 10 FPGA and SoCs are fully integrated into Cortex-2 software, providing the fastest compile times in the industry. The Quartus 2 software design suite includes the QSys system integration tool, OpenCL, the C-based design entry tool, and DSP Builder, a model-based DSP environment within the MATLAB Simulink environment. All these tools save significant time and effort in the FPGA design process for a designer.
You mentioned earlier that there were some specific applications that were early drivers of this need for reinvention. Could you talk a little more about them?
Sure. I already mentioned telecommunications, where the wireless infrastructure, 100 gig and 200 gig networking and data transmission are going into volume deployments, but the need for much greater bandwidth is showing up in other power and cost-constrained applications as well. This is definitely the case in the storage market, where cloud computing is putting flash-assisted storage systems under incredible pressure. And also in broadcast television, the move to 4K ultra-high definition is putting huge pressure on system bandwidth in a very cost-conscious market. And in the military market, we're seeing an explosion of signal bandwidth in secure communications and radar applications, which sometimes may have to be mobile.
Could you be a little more quantitative about what these applications need?
For these applications, Altera has reinvented the mid-range FPGA and SoCs to deliver 15% higher performance than previous generation high-end FPGAs, with 40% lower power as compared to previous generation mid-range FPGAs. In addition, the mid-range FPGA and SoCs now integrate 28 gig transceivers capable of 3.6 terabits per second bandwidth on a platform offering over 1 million logic elements. Because we're maintaining the proven tool environment and architecture from our 28 nanometer families, you can start a design today using Arria 5 FPGAs if power constraints are paramount, or Stratix 5 FPGAs if the critical issue is performance, and then migrate over to Arria 10 FPGA and SoCs when the silicon becomes available. The path to this new definition of mid-range starts right now with tools, development kits, and FPGAs that you can buy today.
Well, Shay, thank you for your explanations. And for those of you watching, thank you very much for your time and attention today. That's all for now.